guys, this is the second video of 3 for chapter 2. We're going to start measurements and types of different basic conversions. So the first thing you need to know on units is that we're going to use SI units a whole lot, and you will be tested on those, so you need to make sure you know them. Okay, there are more, but in chemistry these are the main ones we'll use. Length are meters, mass is kilograms. Now I do want you to know for that one, we will measure in grams for chemistry. However, the SI unit is kilograms. This is the only SI unit that has a prefix from the metric system. So you do need to keep that in mind. That's a common mistake. Time is measured in seconds and temperature is Kelvin, and I know that one's new. We'll start talking about that in chapter 3. So these are just some ways to find the official length of meters and seconds, things like that. Okay, so they all have a way to find them. If you're interested, you are more than welcome to look at these. So there's a standard for length, there's a standard for mass, which is the kilogram, and there's also a set standard for seconds, which is set by the atomic clock. Some of you may have atomic clocks at home, or you may have seen them at the school, things like that. They set themselves. When the time changes, you don't have to fix it, which is nice. So weight versus mass, these are very different things. So mass is measured in kilograms, but that's different from weight. Mass is the measure of how much matter is in it. Weight is that mass times gravity's pull, so weight is also dependent on gravity. Mass is not dependent on gravity. So you may have remembered from middle school that mass, like if we went to the moon, our mass would stay the same, but our weight would not be, because the gravity of the moon is different from that of Earth. Next up is prefixes. So these are metric prefixes. The ones that have the red box around them, you will need to know and commit to memory, because if and when we come back in person, you're going to need to make sure you know them. Now, I do understand that while we're online and we're strictly online, you have access to all of this. But you do need to keep in mind quizzes are timed, tests are timed. Everything we do is going to be timed as far as major grades. So it's going to be harder to continually look things up. It's going to be much better to either have a spot where they're all located at, or a spot where you can just go to it and there it is, or it's in your mind, like it's memorized. All right, so mega and kilo. Kilo specifically, we're going to use a lot. That's 1,000 times bigger than the base unit. And the base unit is here in this space. Okay, so kilo is 1,000 times bigger, so 10 to the 3. Centis 100 times smaller. Okay, you can remember that one was cents, like there's 100 cents in a dollar. So it's 0.01, that's a cent. Milli is 0.001, it's 1,000 times smaller than the base unit. And then nano is 1 billion times smaller. And we'll hit nano in a couple chapters. So choosing your prefix multipliers. I'm not necessarily going to have you do this a lot, but it is going to be important in higher levels of chemistry, even in physics sometimes. So here we've got a number, 1.2 times 10 to the negative 10 meters. So our choices are pico, which is negative 12, or nano, which is negative 9. If I use nano as my multiplier, I would have still smaller than it. But pico, I can have a whole number and then just put the prefix in front of meters as picometers. One thing we didn't talk about before, so we talked about the 4 SI units that we're going to use pretty commonly. Volume is also something we use commonly, but that's a derived unit. And those are units that are made up of different units, like SI units. So volume is normally length times width times height. That's the basic volume. So those are lengths or meters. And of course we can use centimeters, millimeters. Most often in chemistry we'll use centimeters or even liters, which is which y'all are accustomed to maybe with soda or waters, Gatorade, things like that. Now we're going to go into problem solving with unit conversions. I do know that y'all did metric conversions. It may have been a while, so we're going to kind of try to jog your memory. So just remember that units are multiplied, divided, and canceled just like any other algebraic quantities like x, y, things like that. So I do know that sometimes y'all drop things in math, like units especially, but we really need to make sure that we're focused on them, because if you drop units, things come out wrong very, very easily, and that's not what we want. If you're consistent with your units, that every number has a unit, it generally comes out much better. Okay? Don't let units come in and out. Units are there from the beginning and they stay there until the end. If they disappear, it's because you canceled them out, and you need to show that so we know. Okay, so here, this is how we'll do these conversions. It's always the given. That's what you write first. Always in math, you write the given. Then you times it by the conversion factor. And then the given and the given unit and the conversion factor, they cancel. So then all you're left with is the top unit. So here we've got that conversion factor of inches to centimeters. So we can either have it as 2.54 centimeters over 1 inch, or, so there's one way, or we can flip that conversion factor. And you just use it whichever way you want to cancel out your units. It is very important that the unit that you start with is the unit that's on bottom on the next conversion factor so they can cancel. And it always flows this way. It is also very important that you learn how to do this now, because now we're doing things that you do know, like miles and kilometers and inches and time even. But later we're going to change it up, and then it'll be new things that we're adding to it. So step 1, write the given. So I've got 7.8 kilometers. Step 2, do your time sign and then your division for your conversion factor. The best thing to do now is fill in the units. So km has to go down here to cancel. And what goes with kilometers is miles. Notice, I gave you this conversion factor here. And if it's one you need, I'm going to give it to you. I'm not going to give you foot or how many inches are in a foot. I'm not going to give you time units. The rest of them, most of the time, I'll give them to you. I'm also not going to give you metric conversions. So if we're doing like meters to kilometers, you need to know that. That's one of the ones that was boxed in on your chart. So once you have your units, you just fill in the numbers that go with those units. And I thought I brought my calculator in here, but I didn't. So we cross out our units. And then once we have the units we want at the top, if it's on top and it's a number, you multiply. If it's on bottom, you divide. So for this one, it's 7.8 times 6 or 0.6214. And I get, oops, I didn't mean to click that, but I get 4.8 miles. It is important to note that, remember, conversion factors have unlimited sig figs, so that this is our least number, 2, so my answer must have 2. Let's do another one, centimeters to inches. So I've got 56.0 centimeters. From the other slides, it told me that centimeters and inches are related, and in 1 inch, I've got 2.54 centimeters. So my centimeters cross out because they have to be diagonal to cancel. That's the whole point. And this time we're going to divide. Please make sure you always put the given in the calculator first. So I got 22.04, which comes out to 22.0 inches because of sig figs. Next one, meters to millimeters. This is one that you're going to have to know that conversion. So I've got 0.825 meters. Meters has to go on bottom, and millimeters goes at the top. In 1 meter, there are 1,000 millimeters. Okay, so when we had that 0.001, that means that there's 1,000 of them, because that's 1,000th, in 1 big meter. We cross out our unit, so this time we're doing 0.825 times 1,000, which would be 825 millimeters. Let's do another one to kilometers. So I've got 5, 6, 7, 8 meters. Meters still goes on bottom. Kilometers goes on top because it's got to cancel. In 1 kilometer, there's 1,000 meters. So this time I'm dividing by 1,000. So I've got 5.678 kilometers. Ooh, there we go. Okay, now we're going to do some that have more steps, but just a couple for now. So notice in this solution map, they're going from centimeters to feet. So we've got 2 steps. Before, they were just the 1 step. So let's look at one. Here we've got centimeters, 194 centimeters to feet. We have to go through inches because that's what we know. You can't just jump to feet. And here's another one. I'm going to do one similar to both of them, so don't stress out. All right, so always look for your given first. I've got 0.75 liters. I know liters has to go on the bottom. Once I find what goes with liters, that's what goes on top. And here it is, quarts. Okay, so in the 1 liter, I have 1.057 quarts. Liters cancel. Then we need to go see, is that what they asked me? It says how many cups? So a quart is not a cup. So I need to go one more step. That's how I know. So quart needs to go on bottom and cup needs to go on top. And in 1 quart, I have 4 cups. So my quarts cross out. Now, is the thing I have left what it wants? Yes. So when that's the case, we just go right on ahead and do the multiplication and the division. We solve it. I get 3.171, but I'm only keeping 2 sig figs, so I get 3.2 cups. Okay, let's do another one. Cups to liters. So I'm going cups to liters. So now we're going the other way. We're going to use the same conversion factor. So here's our conversion factors from before. So I've got 1.2 cups, which means cups has to go on bottom. 2 quarts. So in 4 cups, there's 1 quart. Cross out cups. It wants liters, so we got to go one more step. 1.057 quarts is 1 liter. All right, this time in your calculator, because they're both on bottom, you need to make sure to divide by both. So the best way to do this is to type in your calculator. So we type in the given, 1.2 divided by 4 divided by 1.057. And I get 0.28 liters. You do need to make sure at the end of all this that it makes some sense. You should know that cups are small. If you've ever cooked anything at home, you know, like the measuring cups fit in the drawers. But liters, which are like what soda is measured in, we don't fit the sodas in drawers normally. So just keep in mind, cups are smaller than liters. You need to think about, does that make sense? Yes or no? If it doesn't, you need to make sure you go back and check it. Okay, let's do another one. 1 lap of a running track measures 255 meters. To run 10 kilometers, how many laps will you run? So this one has 2 givens. Okay, they gave us 2 numbers. That's how I know it has 2 givens. One of them has 1 unit, and the other one has 2. So I've got 10 kilometers. It also told me this in 1 lap. So notice that 255 meters per lap, that is not the given. That's a conversion factor because it's per lap. So my given is 10 kilometers. I know kilometers has to go on bottom, and the only other thing I can get that to is meters. So in 1,000 meters, there's 1 kilometer. Kilometers cancel. Now I can use this as a conversion factor. I know meters needs to go on bottom. lap needs to go on top. 1 lap is 255 meters. So this one, I'm going to do 10 times 1,000 divided by 255. And I get 39.2 laps is 10 kilometers. Some of you may know how many that is. I know some of you could possibly be running cross country or you run track and you know how much a lap is in, normally y'all know in miles or yards, not necessarily meters, but sometimes. Okay. Oh, well, that one I already gave you the answer, but it was the same rundown. This one went from kilometers to miles, and then miles to feet, and then feet to laps. So let's go ahead and do just the work for that one. I just want to pull up, I don't know the miles to kilometers off the top of my head, 0.6214. So this is something I tell you. So 0.6214 miles is 1 kilometer. Okay, so again, we're starting with our kilometers, so 15 kilometers. So I need to get kilometers to miles. Don't forget to cross out your kilometers. Miles to feet, so 1 mile is 5,280 feet. Miles cancel. And then it tells me there's feet in a lap. So in 1 lap, there are 1,056 feet. My feet cancel, and it asks how many laps. So on this one, I'm going to do 15 times 0.6214 times 5,280 divided by 1056. And I'm keeping 3 sig figs, so this is 46.6 laps. Alrighty, here's another one, and this one's a little complicated, but that's okay. You just keep going until you have the unit you want. So here we're starting with nautical miles. How far is the island in meters? So I've got 5.72 nautical miles. So 1 nautical mile goes on bottom is 1.151 normal miles. So nautical miles cancel. And I know that 1 kilometer is 0.6214 miles. And then it asks for meters. Remember, that one's not given to you because you need to know in 1 kilometer there's 1,000 meters. Kilo means 1,000. Once we get to the unit we want, we're good to go. We do our solving. So 5.72 times 1.151 divided by 0.6214 times 1,000. And I get 10,594 meters. Sorry, 95, because that rounds up. But we do need to look, there's only 3 sig figs, so I'm gonna say the answer is 10,600 meters, because the trailing zeros don't count when there's no decimal. So make sure you remember that. You could also say this is 1.06 times 10 to the 4 meters. Either way is okay. Either way is okay for mastering chemistry. You just need to make sure you're consistent and that your number is the correct way, whether it's standard notation or scientific notation. Those numbers are the same number. All right, that's it. I am going to need you to practice some of these because we're going to do some more complicated ones next time. Y'all have a good day.